Alien dictionary. This is a premium hard problem. This is very important problem. This is a new alien language that uses the English alphabet. However, the order of the letters is unknown to you. In our English language dictionary, we use the order like A, B, C, D to Z, means B comes after A, C comes after B, and so on. But in this dictionary, they can follow any other rules. You are given a list of strings, words from the alien languages dictionary. Now it is claimed that the strings in words are sorted lexicographically by the rules of this new language. So if these are the words we are given, then these are sorted based on their new language rule. If this claim is incorrect and the given arrangement of strings in orders cannot correspond to any order of letters, return empty string. That means basically if we have any invalid input, we can return empty string. Otherwise, return a string of the unique letters in the new alien language sorted in lexicographical increasing order by the new language's rules. If there are multiple solutions, return any of them. So, if we consider this string, these words, there can be any rules. The output is WERTF. That means in their language, W comes before E, E comes before R comes before T comes before F. Right? This is some kind of order that we have to find out from this words. Let's take few simple example like Z and X. So that means this is the dictionary. Z comes before X, right? So the order is just one order, Z and X, Z then X. If we see this words list, this is Z comes Z then X then Z means Z comes before X, then again X comes before Z. This is not possible, right? There is a cycle. So this is an invalid input, so we have to return empty string in this case. So we can solve this problem in two ways. One is a topological sort based approach. It's a DFS, post-order DFS based approach. We'll see this solution now. There is also a BFS based approach that we can discuss later. Now consider this words given. So this is a list of words in the dictionary given in this order. Basically they are saying Z comes before X, and also they are saying X comes before Z. We can directly say that this is invalid, but how our algorithm will find it? So if we consider Z and X, we found that Z comes before X. We compare X and Z and we see X comes before Z. Then we are taking this three visiting and visited, these two are set, and this is the output list where I will be storing my output. Now I will come to that, like why we need these two sets, but let's see with an example. We are calling DFS with Z. When we are calling, we are just adding it in the visiting set because we are visiting this character or this node, right? Then we will be doing DFS for all these neighbors. So it has one neighbor, that is X. We are calling DFS on X. We are adding X also in the visiting. Then when you are here, we added X in the visiting set. We have to run DFS on its neighbors. Like X has one neighbor, that is Z. Then we are calling DFS on Z. But here only we will detect one cycle. So here we will see that Z is already in the visiting set. Here only we can return that there is a cycle. So whenever we are doing DFS, we are adding the current node in the visiting set because we are coming in this path, and every time we are visiting a character, we are just adding it in the visiting set. Next, down the line, if we get any path that is coming again back to that node, that means there is a cycle, right? So if anytime we are getting a node that is in visiting set, there only we can decide that there is a cycle. We can return an empty string in this case. Next, come to this example. These words are given. Now we'll consider each two words, like is two consecutive words, and we'll try to find out this kind of rules. So this is basically given like this order comes in the dictionary in this order only. So if we consider this word and this word, we'll see WR and WR both matches, but here there is a difference. T and F are different. That means T comes before F. So this is one rule we got. Consider this one and this one. W and E, they don't match. That means W comes before E. So as soon as when we are comparing this any two words, then as soon as we get a like conflicting character, right? So that defines our rule. It doesn't matter. You see, WRF and ER, W and E are different, so W comes before E. But down, we don't need to check this rest of these characters because they can be in any order. That doesn't matter. Just the first conflicting character we have to check to find out the rule. Next, we are checking ER and ETT. EE matches, R and T doesn't match. So R comes before T. ETT and RFTT. E and R doesn't match, so E comes before R. So we have to do the DFS to find out a solution here. Let's do the DFS for any node. Let's say I'm taking the node T, right? So when I'm taking the node T, I'll just add it in the visiting set. Then I will be running DFS on its neighbor, that is F. F doesn't have any neighbor. If you see here, F doesn't have any neighbor. We added F in visiting set, but we can end this DFS call here because F doesn't have any neighbors. So what you can say, no character comes after F. So F is the last character. What we can do, we can add it in our output. So output will be generating in the reverse order. Now, should we keep these variables in the visiting set? Because F is done, we have added in the output set. Now T is also done. Like when we will come back in T, right? Does T have any other neighbor? No, right? So T also can be in our output. So the question is, should I keep this variables, this T and F in the visiting set, or should we remove it from here? Let's consider the next call. DFS of let's say R. When you are doing DFS of R, we'll add R in the visiting set. Then we'll call DFS of T because T comes after R. So let's see here. We are calling DFS on T, but T is in visiting set. But does that mean there is a cycle? No, right? Because you see, T then F, T then F, right? And we got R, then R comes before T. That's what it means. It doesn't mean there is any cycle, right? So we should move this T and F from here to somewhere else. Let's say F will T. This we moved in a different set, visited set. Means these are already visited. We don't need to think about it. If we get a node like that is in visited set, we can return true that there can be a path like that. So if a character is in visited set, then we can return true. But if a character is in visiting set, that means there is a cycle, we can return the empty string. Done. We are done with R and T. Now what is left? Let's say do DFS on E. Okay, R is done. Okay, when I processed DFS of R, DFS of T is already added in the output, but after we process, DFS R is also done. We can just remove R from the visiting set. We can add R in the visited set and add R in the output as well. because R doesn't have anything like in whatever comes after R is already processed, that is F and T. Now here we are considering DFS of E. DFS of E means we add E in the visiting set, then we'll do DFS on R because R is neighbor of E, right? We see R is in visited set, that will return true. Then we are done with E as well. We'll move E from visiting set, we'll add it in visited, and we'll add it in the output. Next, we are done. What is left? W. DFS of W, add it in the visiting set, then DFS of E. You see, E is in visited set, then we are done with E. Then DFS of W, that W is also done. We'll move it from visiting to visited and we'll add it in output. So we have created the result in reverse order. If you see the output, my actual output will be WERTF. That will be my output. Now, a few things we need to consider here. So we are doing DFS for each character. So we also need to know how many characters are there. Like, so that we can do when we are processing, we are creating this adjacency list or this rule, right? So we are comparing each two words and trying to find out the rules, right? That time only we can keep a character set and we can populate the number of actual characters we have in this word list. One more thing we have to do, consider these three words, right? A, P is matching in three words, but A comes before P in our dictionary, not in their dictionary. Just for our understanding, I am just saying. So A should always come before these two. But consider these two, apple and app, right? So the first three characters, these two are same, and we are out of this, right? Like this, only three characters the second word has, and all these characters are same in both the string, both the word. But if in that case, if the length of the first word is greater than length of the second word, then we have to return false, because this rule we follow in dictionary. One just quick edge case here, like if the input given that has only one word, that doesn't mean that there is no rule given in this input example. Only word means how do you compare? Like it can be in any order, right? So in this case, we can just take the character set. Basically, it will have BAN. That's it, and we'll just return it any order, because there is no specific rule given for this input. Okay. First, let's do some base case. If length of words is 0, we can return empty string because there is no rule. If length of words is 1, then let's return. We'll just take the character set, like set of words 0, the first word, and we just join it. Basically, we're returning in any order, doesn't matter. Next, we have to create the adjacency list. So this is basically will be a dictionary. For each character, there will be a list of adjacent characters. That is basically the characters that comes after this list, after this current character. So we can take a default date of list. Next, we also need to keep track of the character sets, right? So let's take a set for that. Now I'll just go through each of these character words, right? And we'll pair wise we'll do the comparison. And I'm just going till the second last word, because I am taking two words at a time, word 1 and word 2, and that is words I and words I plus 1. So that means we have compared all the pairs. Now for these two words, what we have to do, we have to find out the first non-matching character. So that will define one rule, right? So let's go through the characters. Let's say minimum of length of word 1 and length of word 2. If there is apple and app, I'll just do till the 3, I'll just do the 3 character match, right? So for if word 1 of j not equals to word 2 of j, then we found a rule. What we'll do in the adjacency list, we can add for word 1 of j, we can add word 2 of j. That means word 2j comes after word 1j. And also in every time we are just populating these character sets, because we need to know how many characters we have or what all characters we have. Let's add the characters. Both word 1j and word 2j are different here, so we have to get both. Otherwise, what we'll do, and one more thing, if there's some one character, this two word 1j and word 2j doesn't match, that means we found a rule and we don't need to check for the other rest of the characters, right? We need to break from here, because the rest of the characters can be in any order. That's not required. Now else what we'll do is these two characters match, we can move to the next character, right? But even in that case, we can add the characters in the character sets. Word 1 of j, right? We are done here. Next we have compared the character. If there is any rule, we have detected that. Next, what we'll do, we have to check if there is a situation of this apple and app. So if j equals to min of length of word 1 and length of word 2 minus 1 and word 1 till j equals to word 2 till j and length of word 1 is greater than length of word 2, that's an invalid input. We can return empty string. Next, we have to add the rest of the characters to the character set, right? So let's say we're processing apple and app and apple. We process till app, right? But the L and AE needs to be added to the character set, right? So characters dot update word 1 from j, characters dot update word 2 of j. It's basically any of the word, like which of the word has more characters left, that needs to be added in my characters set. Next, we have to create the DFS function. DFS on a character, and it will take one visiting set, one visited set. Now if character in visiting, then we'll return false. If character in visited, return true. Then I'll just add the current character in the visiting set. Then for each of the neighbor in adjacent of ch, means all of the characters that comes after this character, I'll run DFS with this neighbor, with this visiting and visited set. Now one thing is, if this any of this DFS call returns false, we have to return false, because let's say we are calling the DFS from W, then R, then T. Let's say from T we got a cycle down the line, right? So that will, so T will return false. So from R also we have to return false because T is returning false. Then W also has to return false. So if not DFS, right, immediately we have to return false. That's it. Now after, at this moment, all of the neighbors of this character has been processed. Any character that comes after this character has been added to the output. Now it's time for this character, so we can remove it from the visiting set. We can add it in the visited set. We can add it in the output as well, because this any characters that comes after this has already been processed. And then this is done. There is no cycle. We can return true. Next we have to call the DFS functions. We need a visiting set. We need a visited set. We need an output list. Now we have the character set that we already processed here. These are the character sets. We'll just call for each character in character set. If character not in visited, right, then only we'll do the DFS call. DFS with this character with visiting and visited, right? Now if any of this DFS call is also returning false, then also I have to return the empty string here, because this is an invalid input and we can return empty string from here. So that's it. After all this is done, my output list will be populated in the reverse order, so that we have to return as a string. So let's reverse this, reverse of this output, and we can return it as a string, not as a list. Let's run this. Okay, this works. Let's submit. Okay, now it's satisfied. Now what is the time complexity? Let's say if we have n words, k is the maximum word length, s is the sum of length of all words considering all the characters, c is the total unique characters, then ages is the number of adjacency relations, like how many rows we are having. So now building the adjacency list, that will be for each word, for each character, right? So basically total sum of length of all characters, right? It will be that. So that will be order of S. Topological sort will be for each this topological, this DFS call is happening for each unique character, right? So that will be order of C plus E. E is the number of rules. So total complexity will be order of S plus C plus E. Space complexity, for adjacency list it will be order of C plus E. There are C unique characters, and for each these, like this is basically ages C plus E. DFS stack for topological sort. DFS stack is also will be for unique characters, right? So that will be order of C. So total it will be order of C plus E.